Okay, so what we're going to do in this first video is we're going to solve quadratic equations by graphing them. And if you guys remember doing this at the beginning of chapter 3 with linear equations, it's not necessarily the most accurate. Like we're going to get to a point in the chapter where we'll have some more algebraic methods that are more accurate, but it's good to know how to graph them, and it's good to know how we can see the solutions by graphing them. So first we're going to kind of just describe how you find a solution to begin with. So when we're solving quadratic equations, here's a really important idea to keep in mind. If you are looking for the zeros of the function, so zeros of the function is another word for roots. It's another word for solutions. So zeros, also known as solutions. So if we're trying to solve the function, solutions are the same as the x-intercepts of its graph. So it's like a nice visual way that we can look at it. If we want to solve the function, we can graph it. Once we find the x-intercepts of the graph, then we'll have the solutions of the function. All right, so it looks something like that. So like here's an example. So like let's say that our graph looks like this. And say you're looking right on a grid once you have all these points plotted. This example that I pulled, looks something like this. And like these points right there, it's right where they cross through the x-axis, and so this ends up being the two solutions. So the x-intercepts are -2, which is this one right here, and then +3. So if you find the x-intercepts of the graph, then you end up getting the solutions of the equation. So just for reference, the equation that this goes with is this. And we'll go through a lot of algebraic methods and different ways that we can solve these. But this is just kind of a visual of what we're talking about. Once you find the x-intercepts of the graph, then you'll have the solutions of the function. Okay, so let's look at a specific example. So this first example, we've got x squared plus 6x plus 8 equals 0. So we want to solve by graphing, which means we're going to graph this. So like you get 0 on one side, and once you get 0 on one side, what we're going to do is we're going to graph f of x equals x squared plus 6x plus 8. So if you guys remember doing this with lines, when you replace the y with a 0, what you end up finding is the x-intercepts. So when we find the x-intercepts, we'll have the solutions of the equation. So we're going to graph this and find the x-intercepts. That is our goal. Okay, so here's the best way to do it. This is the technique that I'm going to give you guys. First, you want to find the vertex, so you kind of know what the whole graph is centered around. So we're going to find the x-coordinate of the vertex, -b over 2a. All right, so right over here, what we're starting with is we are going to find the vertex. So we're starting there. So x equals -b over 2a. So negative, remember b is the number in front of the x, so here that's a 6. Over 2a. A is the number in front of the x squared, so that's just a 1. So we end up with -3. So normally when we're graphing and we were setting up a table, we were kind of random on the way that we pick the x values, but this way we know that this is kind of like a jumping off point. So when we set up our table, we can do like xy values, and we're going to center it right around -3. So we're going to go 2 up, 2 down, and that's usually a good starting point. So we'll go 2 down to -5, and then 2 up to -1, and that'll be a really good place to start. Okay, so we're going to plug these values in here. So if we plug in -5 squared, we get 25, plus 6 times -5, so -30, and then plus 8. So we combine all that up, we get a y value of 3. Then plug in the -4. -4 squared is 16. 6 times -4 plus 8, and so that gives us 0. Plug in -3. -3 squared is 9. 6 times -3 minus 18, and then plus 8. So this gives us a -1. Plug in -2. -2 squared is 4. 6 times -2 is -12. Plus 8, that's also 0. And then plug in -1. -1 squared is 1. 6 times negative 1 plus 8. Okay, so this is going to give us 3. Okay, so you can see we've got this symmetry going with our y values. So we're going to plot these points. So we're kind of skewed over on the left-hand side here with these values. Okay, so negative 5. Okay, so we're just going to plot these 5 points. So negative 5, positive 3. So we'll go over to negative 5, up to positive 3. Then negative 4, 0. So that's right on the x-axis. So that's one of them. That's one of our x-intercepts. Then negative 3, negative 1. And remember, we found that this is actually negative 3 is the value of the vertex, which means that's the axis of symmetry right here. Then negative 2, 0. That's right on the x-axis. That's our other x-intercept. And then negative 1, positive 3. Okay, so this is our parabola right here. So by starting with the vertex, we were able to kind of center around where our graph is going to be. So our solutions are x equals, and we're just writing down the x-intercepts. So negative 4 is one of them, and then negative 2 is another one. So we could check. So what we're saying is that these two numbers right here make this equation true. So you could plug them in, and that's actually a good calculator check that you guys could do. So, if we take negative 4 and store it in for x, so remember you hit Control and then hit this button above the 9 to store, and store that in as x, and then I'm just going to type this equation. X squared plus 6x plus 8 equals 0, and when you plug it in, you'll see that you get a true, which means that negative 4 is a solution to that equation. And then we can check the negative 2 as well. So take negative 2, store that in as x, and then rather than type this whole equation again, I'm just going to arrow up, copy it. When you hit enter, you'll paste it, hit enter again to check, and they are both true. So negative 4 and negative 2 are the two solutions to this equation. Okay, so there are 3 possible outcomes. I just got one of the possible outcomes. So let's pretend, just for this sake, that A is positive, so it opens up. We could have the exact same 3 cases if A opens down. So 3 possible outcomes when solving a quadratic equation. We could have 2 solutions. That's what we just found. And that would look something like this. Like that. So 2 solutions means we've got 2 x-intercepts. You could have a scenario that's kind of rare, but we want to keep an eye out for it. One solution would be if it just perfectly bounces off the x-axis just in one point and then goes off from there. So it would literally just have one x-intercept because that's kind of a bouncing off point. And then it's also possible to have no solution, and that would happen if the parabola turns around before it actually hits the x-axis. So something like this. Okay, so any of these 3 are possible. It's not possible to have more than 2 because the parabola just goes down and then goes back up, so it couldn't possibly like wiggle around and hit more than twice. Okay, so now let's solve this one by graphing. So first thing we're going to do is move this 4 over. Okay, so remember, what we're technically doing here is we're taking this as a function and then plugging in 0 so we can get our x-intercepts. So what we are doing, once again, we are going to graph the related function and find the x-intercepts. So that's our goal here. And just like the one up above, the way we're going to do that is by finding the vertex first. So the vertex is going to be kind of our jumping off point. Okay, so negative b would be a negative 4. That's the number in front of the x. And then 2 times 1. So the x value is 2, so that's where we're going to start. So we're going to go again 1 up, 1 down. I'm sorry, 2 up, 2 down, just like the previous example. So from 2, we're going to go 2 down to 0, and then 2 up. So those are the values that we're going to plug in. Okay, so we're plugging these values into this equation right here. Technically, this function over here. So plug in the 0. 0 squared is 0, minus 4 times 0, and then plus 4. So our first y value is 4. Then we plug in 1. 1 squared is 1, minus 4 times 1 is 4, plus 4. So we end up with 1. Then plug in 2. 2 squared is 4, minus 4 times 2 is 8, plus 4. this ends up giving me 0. So remember, if you get 0, that's one of your x-intercepts. 3, if I plug in 3, 3 squared is 9, minus 4 times 3 is 12, plus 4, so this gives me 1. And then plug in 4. 4 squared is 16, minus 4 times 4 is 16, plus 4, so the 16s cancel, and I'm left with 4. So those are the points that I plotted. So let's see what the graph looks like. So we're more skewed on this side this time. So we got 0, 1, 2, 3, 4. Okay, so start with the point 0, 4. So that's actually my y-intercept, if we were looking for it. 1, 1 would be right here. 2, 0, that's right on the x-axis. That's one of my x-intercepts. 3, 1 would be the next point. And then 4, 4 would be the last point that we have on our graph. So remember, the value of the vertex is x equals 2, so that would be this dotted line right here. So that's the axis of symmetry, meaning we have a symmetry around that line. So when I graph like this, that vertex is the one and only place where we're going to hit the x-axis. That would be this scenario right here. So we just have one solution. So the only solution that we have is this one value right here of x equals 2. So that's the only value that would make this equation true. And you can actually just check it by plugging in real quick. If you plug in 2, 2 squared is 4, minus 4 times 2, which is 8. So 4 minus 8 does in fact give us negative 4. It's the only one that would work. Okay, last example for this video. Kind of a little story problem here. We want a quadratic equation to find two real numbers with a sum of 4 and a product of 5. Okay, so the way we're going to do that is we'll say like let x be one of the numbers. Okay, so the first number is x, and then we don't want to use a second variable. We want to keep it all in terms of one variable. So if they have a sum of 4, what that means is that for the second number, we can write 4 minus x. Okay, so 4 minus x would be the other number, because whatever this number is, when I add them together, I get 4. So 4 minus x would give me the other number. All right, so those are my two numbers here. And I came up with this number just based on that. So if they say sum of 10, this would be 10 minus x. If they say sum of 100, this would be 100 minus x. And the product of 5 is the part that we're actually interested in. So it says use a quadratic equation to find two real numbers with a sum of 15 and then a product of 63. So when I multiply x times 4 minus x, sorry, I said 63 because I was reading out of the book, this product would be 5. So the sum is 4, which is where I got this from, and the product is 5, meaning when I multiply them together, I get 5. So we're going to clean this up and then solve for it. So I can distribute this x. So x times 4 gives me 4x. And then x times negative x, be minus x squared, equals 5. Okay, so I can go through and I can come up with the exact same thing that I was doing up there. So I want my x squared to be positive. It's easier to solve that way. So I can move that over to this side. So I'm going to have 0 equals positive x squared minus 4x plus 5. Okay, so I'm going to graph the equation. So first I'm going to come up with my vertex. X equals negative b over 2a. So negative negative 4 would be positive 4, and then over 2 times 1. So I know my vertex is going to be 2, so I can use that to make a table. So I will make a horizontal table here since I'm kind of running short on room. So 2 is right in the middle, so I go 2 up, 2 down. Okay, so I guess we're going to do a lot of the plugging in our head. So this is the equation that we're plugging into. So 0 squared minus 0 plus 5. So this gives me 5. When I plug 1 in here, 1 squared minus 4 times 1. So 1 minus 4 is negative 3, plus 5 is 2. And I plug in 2. 2 squared is 4, minus 8. So 4 minus 8 is negative 4, plus 5 is 1. And plug in 3. 3 squared is 9, minus 12, that's negative 3, plus 5 is 2. And then plug in 4, 16, minus 16 is 0, plus 5. Okay, so those are my values. I'm going to plot those. 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay, so 0, 5, that would be my y-intercept right there. 1, 2 would be right there. 2, 1, 3, 2, and 4, 5. So we plot all these points, connect the dots, make our parabola. Whoops. There we go. So now this one actually falls into this scenario where there is no solution. So this particular equation that we were looking for actually has no solution, meaning there's apparently no such thing as two real numbers that have a sum of 4 and a product of 5. All right, so that's it for this one.